Hello, my name is Rajat Sagar and I'm a system architect on ADAS processors team at Texas Instruments. And I want to welcome you to part 3 of our TDA2 EVM video series. In this video, we will talk about running a deep learning based demonstration on a TDA2 EVM, and we will walk you through the setup process. This demo is called semantic segmentation. After watching this, you will be able to run semantic segmentation use case and start your own ADAS system development on the powerful TDA2 platform. So let's get started. In part 2 of this video series, we had talked about TDA2 EVM setup along with other application cards. But in this video, we will only focus on TDA2 EVM and the necessary setup components for this demo. If you have received a brand new EVM, please watch our TDA2 EVM unboxing video for setting it up from the basics. Before we start with the EVM, let's briefly talk about the use case that we will be using for this demonstration. Like I said before, this use case is called semantic segmentation. It's based on deep learning technology, which is implemented using TI Deep Learning software library. TI Deep Learning library is an efficient implementation of deep learning kernels and layers on TI processors. It not only abstracts the complexities from user, but allows for a much easier and efficient user experience. So what is semantic segmentation? Semantic segmentation is also called pixel classification. It basically partitions the image into semantic or meaningful parts and labels each part. And as you can see on the images on the right of this slide, on the top we have the input image, which is really a snapshot in time from the input video. And on the bottom, we have the output from semantic segmentation deep learning network, which basically encodes each pixel or labels each pixel of this image into some meaningful classification. Like you see, vehicles, roads, signs, people, and background is all classified. And this information forms the basis of scene understanding, which is required for algorithms in higher level of autonomy. All this is implemented in a very low power budget of 2.5 watts. There are many more details about this use case on what we have done and how we have done and how this allows you for further development on deep learning use cases. I'm not going to cover that in this video today. For more information, please refer to the user guide and documentation available in Vision SDK, which is the software release we offer as part of TDA2 EVM. Now let's talk about the hardware setup. The hardware setup for this demo is very simple. As shown in this slide, it's basically 3 components. We have a SD card where the input is stored. Input is primarily the application binary, the input video file for the scene, and the deep learning network. It goes into the TDA2 EVM via the SD card slot. The actual use case is running on a TDA2 SoC, and the output is visualized over HDMI on a monitor. With that, let's get started. So let's see what do we need for this demo. For this demo, we need following items. Number 1, we need a TDA2 EVM. Number 2, we need the power supply for that EVM, which comes along with the box. We need a high capacity SD card. We recommend 4 gigabytes or more. We also need the latest Vision SDK software release. This software release will provide you pre-built binaries which are required to load and run this use case, along with all the deep learning development infrastructure. We also need a USB cable, which needs to be USB mini B type to USB A type. We use this to connect to the EVM, the serial terminal from the EVM to the laptop or a PC to watch for debug and control messages on a serial terminal. We need a HDMI cable to connect the output from EVM to the monitor. and a monitor capable of HDMI input. Along with that, most importantly, we need access to a PC or a laptop with a USB slot and a SD card slot to load this demo from Vision SDK release into the SD card. So let's get started with the connectivity. First, we connect the serial prompt terminal. So for that, we have used a mini USB cable, which is from type B to type A. As you can see, I've connected the type B to the mini USB port on the EVM. This port is marked with a label called terminal, so you have to watch for that. And then just connect it to the laptop. We need to make sure that the laptop supports a USB to serial driver, the driver is installed. If it is not installed, we have provided a link to the appropriate drivers in Vision SDK software release. Please look it up and install in the PC or the laptop to ensure that the serial port is understood. Next, we need to open the serial terminal application on the PC and make sure it's configured with the right configuration to support the communication with the EVM. To do that, as you can see in my PC, I've already done that. The configuration I've chosen is 115/200 baud rate. This whole configuration is again available in the documentation as part of Vision SDK release. So while I've done it here, for more details, you can refer to the documentation. Once it's configured, we press OK, and with that, the serial terminal is connected. The next step is to connect the HDMI cable from the EVM to the HDMI monitor. And make sure that the power supply to the monitor is powered up, it's ready to go for displaying whatever the HDMI has to output. Now let's come to the application. For running the application, we need to load the application in the SD card. These binaries are default compiled and available as part of Vision SDK release package. I will leave a link towards the end on the actual directory where these binaries are. But we need to take these binaries and load it in an SD card. So I drop in the SD card into my laptop. In the SD card, I have following files copied from the Vision SDK release into the SD card. Basically, just to give you a quick overview about these files, first we have the MLO, which is the bootloader, standard bootloader. App image, which is the application image, which really loads on all the processing cores and is responsible for loading the deep learning network, the parameters, and running the actual application. The actual deep learning network is called dlnet.bin, so it's a binary file which represents the network. Along with that, we have dlprm.bin, which is the coefficients or the database associated with this deep learning network. And then we have the input data. The input data is present in two files. The first one is called in-data. In-data is really the raw input video in H.264 encoded format. In-header is the index of that H.264 video. To show you what the input video looks like, I have this file opened up in a VLC player on my laptop, and as you can see, this is how it looks. This is a raw video captured from a camera, for a forward-looking camera from a vehicle, and this is what we will use to run our semantic segmentation network. Now, with this copied, we need to insert the SD card in the SD card slot on the EVM. I've already done that with the same files copied. Now let's power up the TDA2 EVM and see if it boots properly. If the binaries are copied correctly to the SD card, then the EVM typically just boots properly. And as you can see in the Teraterm, this is my serial terminal window. as the EVM boots, you get these bunch of messages of booting. First, the standard bootloader loads, it loads the application image, and then it boots and stop at this prompt. In this prompt, the application presents us with these multiple options of running different use cases. Most of these use cases have dependencies of either having an external camera sensor or having other vision cards or other application boards that we have covered in part 1 and part 2 of this video series. For this demonstration, we are going to select option G. Option G is labeled as semantic segmentation and use case. This has no dependency on any other hardware required along with the TDA2 EVM. And as soon as we select it, it's going to go load that deep learning network, load the data from SD card, and start loading the use case. So let's select G and see what happens. So now that I have selected option G, as you can see, there was a slight moment of slight delay due to the loading of use case, but now we have the semantic segmentation demo running live and shown on this HDMI monitor. So there you have it. This was deep learning based semantic segmentation demo on TDA2 EVM. On behalf of Texas Instruments, I want to thank you for tuning in. We can't wait to see you get started on our TDA2 processors to create innovative technologies that help safer driving for years to come. For more information, please do log on to ti.com/TDA. Thanks for watching.